So today we're going to continue studying about integrals, and now we're going to study about the trigonometrical functions, right? So, they would be sine, sine and cosine. We have cotangent. We have a secant. We have cosecant. Cosecant. Have cotangent, cosine, and sine, secant, cosecant, and yeah, I think is it tangent, cotangent, sine, cosine, and cosecant, and yeah. So let's suppose we have an integral. I'm going to denote with this bar here, but actually we know it's like this. But as I don't have this, okay, so I'm going to do this on writing. So let's say we have integral of sine to the n, okay, x, ax, okay. So we know that sine squared x is equal to 1 minus cosine of 2x over 2, I guess. Yeah, over 2. And so let's say we have, I don't know, like for example, sine to the fifth, to the fifth of x. So that is the same thing as sine squared of x, and this squared times sine of x. So when we so we know that this is the same thing as 1 over cosine of 2x over 2, and we squared this and times sine. So over 4, 1 squared is the first square minus 2 times the first times the second, 2 cosine 2x times the second squared, which is cosine squared of 2x times sine x, okay? So we have sine x minus 2 times cosine of 2x sine x plus cosine squared of 2x sine x, okay? And we can divide this in integrals. So we have the integral of sine of x minus 2 times the integral of cosine of 2x. Actually, I'm not going to write all over again. Just put the integrals. So I have integral here, integral. One integral over here, one over here, and one over here. Cosine square. Okay, so now I'm going to write. So let's leave the first one last. So we have integral of sine x plus, actually minus 2 times int of cosine and sine. So we know that the derivative of sine, so d sine x over d, I don't know, theta, anything, is, so the derivative of sine is negative cosine, okay? Cosine. So here we have sine x. So this would be the same thing as u over this, okay? Actually, no. This would be u times its own derivative. So we can leave this only with sine. So this would be sine x times du. But actually this 2 here should be down here because it's 2 and it has to be a negative because of the sign, okay? So actually what we have to do is that the derivative of sine u, okay? Let me just write it because it's better. So the derivative of sine u, we're going to, let's say, over dx. This is equal to sine u, okay, sine u cosine u times, this we use the chain rule, is cosine u times the derivative of u in relation of dx. Dx. Okay, so yeah, so then this would be cosine of 2x. Oh, let me do this down here. So it's the integral of sine x cosine of 2x, sine x cosine of 2x, okay, dx. So the derivative of sine x, the derivative of sine x is equal to cosine x, okay, but here is cosine of 2x. So put a 2x, wait, what? Sine x and sine of 2x. Yeah, okay. Sine of 2x. And we had a 2 over here, and we divided by 2, so this 2 cancels out. Okay. And, well, this then is go, if we divide, let's go sine of 2x, and then we divide by 2, okay? And so we have integral of sine x. We can take this out, only divide this by 2, and we have dx. So what we do is we sum 1 over here, so then we have so we have sine squared of x divided by 2, but then we had 2 back there, so it's 4. Okay, and now we sum this with cosine squared sine x. So the derivative of cosine is sine. Okay, so then it would be cosine. The derivative of cosine is of cosine 2x is the derivative of sine with cosine, which is sine 2x times 2. But as we only have sine over here, we have to divide by 2. So then would be this plus sine 2x, and we have to multiply by 2 over here. And plus the derivative, the integral of sine is cosine x. So that's it. And it's the same thing for cosine and the others. I just wanted to show kind of how it works.